Welcome to the first lecture, video lecture of the class. We're going to start out by talking about what is DevOps in a little more detail than we did in the intro. So in particular, we'll talk about the motivation for DevOps and then a little bit about DevOps itself. So we'll start by talking about the velocity of releases. Traditionally, organizations deployed a new release quarterly, monthly. In the modern world, this is way too slow. Internet companies deploy multiple times a day. So Etsy is a online art store, sort of like the Amazon for art. They release 90 times a day. Facebook's releases 2 times a day, not because they couldn't do more, but just because they want to minimize the disruption to the developers. And this data now is getting pretty old, but Amazon had a new release to production every 11.6 seconds in 2011. So this is not monthly. So why were releases historically so slow? So first of all, why do we have a release? Well, there's a requirement for a new release. It could be an idea for a new feature. It could be a merger between two organizations, right? You have two banks merge, and all of a sudden you have two account management systems. You have two things to manage deductions. You have two things to manage your employees, and so on and so forth. So you got to get rid of one of them, or merge them, or do something. It could be that you have a system in production and there's something wrong with it, either a quality problem or just looks old-fashioned, if you want. It could be desire for better efficiency. And in any case, there's a requirement for either creating a new system or modifying an existing system. In these days, modifying an existing system is by far more common than building a new system. So how does it work? Well, the board has an idea, says, we need to implement a new feature. And they throw it over the wall to the developers. The developers go ahead and implement it, and they throw it over the wall to operators. And while the developers are implementing and the operators are putting it in production, time is passing. So what's the process? Well, you get requirements, right? Whatever the cause of the new release is, it has some requirements, and they can be done in documents. They could be done in user stories. It could just be that the developers are given some intuitive description and they have to figure out what they're supposed to do. In any case, the requirements are divided into teams and they're assigned to various development teams. And so each team has a set of requirements that they work on in some fashion. And at some point, they feel like they've satisfied the requirements and their code is complete, so they're done. Not so fast. Code complete is not the same as code in production. Between the completion of the code and the placing of the code into production is a step called deployment. And deploying completed code can be very time consuming because of the concern about errors that could occur. And this is one of the sources of delay of releases. So before we get to the errors, what's the workflow? Well, you as a team develop and test your code fundamentally in isolation, and then it gets integrated with code developed by the other teams, and you try and build an executable. If that build is successful, then it's tested for correctness, and once the built system passes its correctness tests, then it's tested for performance and other qualities. That's called staging. Usually you don't hear too much about staging. And then the built system is placed into production. Well, what can go wrong? Almost anything. So let's suppose at the integration step that another team hasn't completed yet. Can't integrate because you can't integrate their code. Let's suppose that you're using some third-party software and they're not ready yet. Same problem. What happens if there's some inconsistency between the names and the methods from the other software, the ones that are calling you or the ones you're dependent on? You have a contract in terms of how your system is supposed to be used. You call the initialization routine, followed by a call to some operation routine, followed by some call to a cleanup. Your clients, the other team that is dependent on you, may not follow the contract, and so they may do something wrong. Okay, this will show up in integration, and there'll be a problem. Version incompatibility. You're using a third-party software. You say we're going to use version 2.8, and it happens that the other team is using version 2.9. And third-party software, or actually any software, people are not very good about keeping compatibility between versions, and so you can get errors caused by your use of 2.8 and their use of 2.9. What else can go wrong? Well, you have a database that you're driving your tests from, and it may be that it doesn't get refreshed, and that means the tests aren't repeatable. It may be that the data doesn't get to where it needs to go in your code. Maybe you have configuration problems. Okay, so there are whole bunches of configuration parameters that you set, and the ones your team sets are incompatible with the one another team sets. You said we're going to assume that we have a thread pool size 10, and they say we assume we're having a thread pool of size 20. Okay, well, this can cause problems. It could be that certain configuration parameters aren't specified and nobody bothered to put a default, or the default that they used didn't make sense in a particular context. You can't reach external services. Okay, you needed to get some sort of authentication from an authentication server, and you can't get that because you don't have the right keys, or your configuration parameters are set up, and there's just a whole raft of things that can go wrong. What can go wrong in staging? Well, many of the same things. Okay, so you have configuration problems, you have data problems, and so on. And so at staging, you're testing for performance, and maybe your database isn't big enough, and maybe all of a sudden your database is big enough and your system doesn't work well under load. So there are whole bunches of things that can go wrong. Same kind of thing in production. Configuration problems. That's a way of managing your authentication. You have to have keys. They have to be kept securely. Maybe you can't get at them. You have inconsistent configurations. Maybe this is the first time your system's worked under actual load, and it may not have adequate performance. There may be logical problems, okay, and maybe that you need to roll it back. So I put it into production. You say, whoops, doesn't work right. Let me roll back to a previous version. Or maybe the database got corrupted in this. So again, a whole bunches of things that can go wrong. And all this time is passing. Okay, so every time you have an error, you have to fix it. So correcting an error takes time. So what you would like to do is prevent errors. So how do you prevent errors? Well, partially that's a process. We use a certain process that's designed to prevent errors. Partially that's architecture. If you have the right kind of architecture, then certain errors will be avoided. Partially it's tooling. Okay, so you have automated tests and other kinds of things that check your code. And partially it's coordination among teams. So a lot of the errors that I discussed during integration could be solved if you spent time talking to the other team. But time is your enemy in this process. So coordinating takes time, correcting errors takes time. So we would like to avoid errors and not have to do it through coordination of teams. And that's sort of one of the implicit goals of DevOps. So again, historically releases were scheduled for once a quarter or once a year. And this is a time to market issue. So the board is concerned, Our competitor is coming out with a new feature next week. Why is it taking us 3 months in order to do that? Okay, we knew this was coming, because we haven't scheduled a release, that's a flimsy excuse. And so these days there's a lot of pressure to get time to market. Okay, so what is DevOps in this context? Well, DevOps is a set of practices intended to reduce the time between committing a change, between the time your code is done, and the change being placed into production. Okay, and you want to do this while you maintain quality. So quality is important in this. And this involves developers and operators, hence the DevOps. It involves architecture and involves tools. It's also a movement called like Agile, so you can talk about the DevOps movement. And so the terminology is a little bit shaky here. But you can look at the DevOps processes and divide them into three categories. You want to reduce errors during deployment, the kind of errors that I was discussing. You want to speed up the deployment process. You want to make it faster. And you want to reduce the time to resolve discovered errors. So an error in production is called an incident. You have an incident, and then you have to fix that incident one way or another, resolve it. And so you want to reduce the time that it takes to do that. So how do you reduce errors during deployment? Well, one technique is to use microservice architecture, and we'll get into that in a great deal of detail. Another technique is to enforce deployment practices uniformly across both developers and operators. Historically, developers have developed a set of processes that they use to reduce errors, pair programming, for example, or unit tests. Operators, not so much. I mean, these days more, but operators tended not to have the same set of processes that developers used. And so when they say enforce deployment practices uniformly, they're really focusing more on the operations side. You want to develop infrastructure code using the same processes as applications. Again, same kind of concept. And you want to automate. Automation becomes a key factor of DevOps, in the sense that it reduces errors during deployment because things are going to be automated, meaning they're scripted, meaning they're repeatable, meaning that you can, once you fix the script, then it's just a matter of invoking the script. And you'll see an awful lot of that when you start doing the exercises and so on. How do you reduce the time to deploy? You use a continuous deployment. So you have a deployment pipeline, which we'll discuss in some length, and everything is automated. So you commit your code, and from then there's no human intervention until the thing actually goes into production. Well, that's not always possible in certain contexts, but that's the concept. And you want to make it all automatic. Again, no humans involved. How do you reduce the time to resolve discovered errors? One is you treat operators as first-class citizens. So software engineers have been told that stakeholders are important. They should listen to stakeholders, and that usually translates into customers, the users, the end users. Sometimes it translates into developers. Okay, so what are our requirements for developing? But it tended not to translate into how is this system going to be operated. And part of the DevOps, or the motivation for DevOps, was the realization that it was hard for operators to install and operate systems because of essentially sloppiness on the part of developers. So if you can gather requirements from operators and then adhere to those requirements, then their problems will be reduced. And the second technique is to make developers more responsible for incident handling. So we'll talk about that as well. So just to summarize, DevOps is motivated by a desire to reduce the time to market for changes to the system. Historically, releases were scheduled, taking months. Now you can release much faster. And the definition of DevOps is a collection of processes whose goal is to reduce the time between commit, when your code is complete, and normal production. And these processes, the DevOps processes, either prevent errors or they speed up detection and the correction of errors. And we'll get into all of this.